Okay. Alright. Hello, my name is Kyle de Guzman. This is my platform simulation final. So first we're going to go over my project organization. So I broke this into 3 parts, which are prefabs, scenes, and scripts. So first we'll go over the prefabs. The first prefab is a 3-dimensional cube. It was a unit cube that was scaled down along the y-axis to flatten it. I used this as a base layer for the platform, and it was also renamed nodes so that when the platform is built, we will see it in the hierarchy as an array of nodes, like node 1, 1, node 1, 2, node 1, 3, and so on. Next, we have my scene changer prefab. This prefab is an empty object with a script attached to it. This prefab is placed within a scene so we can change the scene whenever a button is clicked. So now we can talk about scene. So this is my configuration screen. All of the objects in the scene are stored within a canvas container, and within that canvas container we have 3 containers, which are top panel, configuration setting panel, and the programming settings panel. I found organizing them into containers helped me move all the objects easily. Before I did that, I would have to move each text box, and slider objects individually, and grouping them together helped me move all of them together. Also, I learned that hierarchy matters. The hierarchy determines which objects are laid on top of other objects. And as you can see, the scene also has the scene changer prefab that we talked about earlier. And it also has a platform manager and other objects that are simply there to hold the scripts. So this is what it looks like to the user. However, when the user is using this, only one of the configuration boxes are shown. And that's done using scripts. So next we have the main menu scene. The main menu has the canvas with 4 buttons, which are configuration, programming, simulation, and exit. So the buttons, configuration, programming, and simulation lead to 3 different scenes of the same name, whereas the exit button exits the editor. So if this was downloaded as a program, I would have to tweak the code a bit to exit the window, because right now it only exits the editor. Next slide. This is what it looks like to the user. So here we have the programming scene. It's basically the same thing as the configuration screen. It has 4 new buttons at the top right, and the text were also rearranged. And the panels also have different placements. As you can see, the configuration panel and the programming panel are laid on top of one of each other. And this is what it looks like to the user. However, when you actually play the program and you execute the program, only one of those panels will be right here. Only one of them will be visible. So it's not going to look messy like that. Alright, so next slide. And this is what that looks like to the user. Oh my bad, no. Alright, so here, this is the simulation scene. The simulation scene looks pretty much like the programming scene. However, there's no more configuration or programming panels, and also this button, instead of saying simulation, it's now programming, so you can go back. And that's what that looks like to the user. Okay, so moving on, we have a total of 11 scripts. Not all of them are used in the program because integrating some of them was a difficult task. So first, let's start off with the scene changer. And we're starting off with scene changer because that's the easiest one to explain. And so that's how I'm going to go. I'm going to explain them from easiest and shortest to more complex. Alright, so first we're going to start off with the scene changer. So scene changer uses Unity's scene management library, which is right there, and that allows us to access the scene manager class. So this script has 2 functions, right here and right there. So one of them is to change a scene, which will take the scene name as input, and it will load the new scene. And then we also have the next function, which is exit, and like we said earlier, this just quits the editor, and that's right there. Unity editor dot edit application is playing, and then we're going to set that to false. And if we wanted to quit the window, like a regular program, we're going to have to change this. So let's move on. Okay, so here we have the platform configuration data script. So this is a class that we will use to create objects. So it will contain information about the platform, such as the length, which is right here, the width, which is right here, spacing, which is right here, and the height. So how high and low these nodes can go. And by low, I mean below the 0, 0, 0 on the grid in the world. Anyway, so that's what that is. And again, we're going to use this to create objects. So for example, we'll see that later. Alright, so here we have the singleton class. So we're essentially using singletons to allow only one version or instance of a script to exist in the entire game. Because without doing this, if you assign multiple 3D objects a script, they're all going to have a unique version or instance of the script. This means they all hold different values for the class's properties. So for example, if we go back to the previous slide, if we have multiple objects that use this script, all of them are going to have different m values, all of them are going to have different n values, different spacing values, and different height values. And so by using singletons, all the objects are going to be using the same instance of a class, meaning they're all going to share the same values. So for example, they would all share the same m values, all the same n values, all the same delta space values, and so on. So singleton allows us to do that, right? So now let's look at the code. So as the scene is loading, we're looking right here at the wake. So as the scene is loading, if there's no instance of the script, we're going to make this the official instance of this script. And if there is already an instance of a script, that means we don't want another instance, so we're going to destroy it, and that's right there. And again, it's the idea that we only want one version or instance of the script to exist. Also, it's saying that as we enter new scenes, we want to make sure that we don't destroy our official instance of the script, right? So for example, if we go from scene to scene to scene to scene, at the beginning of each scene, we want to make sure that the garbage collector doesn't erase our instance, right? Because without this, these scripts will renew itself in every single scene, so we want to avoid that. So luckily, the implementation of this does work. If you do go from scene to scene to scene, the values for m and n, they are consistent throughout all the different scenes, and so luckily that works. Alright, so earlier we said that we had 11 scripts, and I only went over 3, I believe. So now, in the next few slides, I want to dive deep into the UI manager script, the platform manager script, and the data node script. But before we get to that, I want to quickly run down over the 5 remaining scripts that I'm not going to talk about into detail as much. So 2 of the remaining scripts are simply camera-related scripts, which are given to us. Another script called NoDestroy was my own implementation of a singleton, and then I ended up changing that to the singleton class given to us. And that was mostly so everything could be integrated nicely. And lastly, we also had an exit class. So the exit class was originally for button handling and scene changing. However, that has been merged with different scripts like the platform manager script, the UI manager script, and the scene changer script. Alright, so now that that's cleared, we can move on. Alright, so the UI manager script has 245 lines, so I'm going to go over the highlights, the ones that I think are really important. Okay. So here we have delegates, delegates and event declarations. So this is a delegate right here. This is the event declaration right there. Okay, so I broke them down into groups of 2. So right there, right there, right there, which is what's to be expected. So public delegate void is basically saying that this event exists, and these are the parameters. And then public static event is simply giving that event a name to be referenced by. So for example, right here in the first one, we have build platform on clicked. So that's the name that we're going to reference it by. We have on update camera position, so that's the name we're going to reference this event by. We have on node program change, and that's the event, that's the name we're going to use to reference this event. And also have on write program data. Okay, so here we see a bunch of public variables, which include text right here, input field, slider, drop down, more text, and we have game objects. So these are all public, so we can drag and drop 3D objects in our scene to use them as values for these variables. This essentially allows us to manipulate these objects within our scene. And by making these variables public, we can avoid the hassle of searching all the objects within our scene using getComponent. So another thing I want to highlight is onEnable and onDisable. So onEnable is basically referencing an event from another script. We're enabling the event. Then later we define the actions to be taken when the event is called, and then we disable it when we're finished with the event, and that's right there. So we have onEnable and onDisable. So the plus equal combination right here is not mathematics. It's used to enable the event, and the minus equals right here is used to disable the event. So as you can see, these events come from Platform Manager and Platform Data Node. And just a reminder, again, we're in the UI Manager class right now. Okay, so next slide. Okay, so in this example, this is an example of outlining the instructions for an event. So let's go over this very first one at the top. So the first one is basically saying if there's already an assigned height that the node can use, we want to use that height value to update the slider. So for example, if the user sets the random height to 5, we want the slider to update itself so the UI matches the data that we have. And then on top of that, we also want to update the text that displays the value of the height. So again, if the height says 5, if our data shows that the height is 5, we want the text to display what our data says, right? Okay, so then in the second event, it's basically saying that if we have a value for any of the text that we're displaying, then we display that value. So for example, if we have a value for m, n, spacing, or height, then we want to update the UI. So next slide. So also within our UI Manager, we handle slider events. So if the user provides input to the spacing or height sliders, we want to collect that data, and that's what this entire section does. It's just collecting data from the sliders when the value change. That's important. Okay, so then, and similar to the previous slide, we want event handlers for the buttons. So if a button is clicked, we want certain actions to be carried out. So this outlines those instructions, and that concludes the UI Manager script. Now we can talk about Platform Data Node script. And this is the script for when we're on the programming scene. Okay, so next slide. To start off, we have an event delegate and an event declaration. So the delegate will always state whether or not there's input for the event, and the second part, which is the public static event, will tell us the reference name we can call to manage these events, and that's right there. So the next, we also declare variables. So these are public, so we can drag and drop items within our scene and make them accessible to the script. So in this case, we have 3 booleans: simulate and program help us determine which scenes that we are on. I and j are for the m by n values of our grid. Text is for the text that we want to be displayed. Slider is a 3D GUI slider. An image is unique. So I experimented with it. I put different values to it. I think it can be used for canvas and panels. It can also be used for buttons, I think, but I cannot figure out what it's for. And it's the major source of all of my issues and why I think it is. I think it's the major issue for why I have errors throughout my project, and I cannot figure it out. So next slide. Okay, so here we have on enable and on disable. So last time I rushed the explanation a bit, so let's take some time to understand this. So events are shared among different scripts. We need some objects or scripts to declare and create an event. Then that event will be triggered, and then we need another object or script to handle that event. So a good example of this are button clicks. We create the button in Unity Scene Builder. Then in the Inspect tab, we have the section that says on click, and you can determine what happens when the button is clicked. This is the same principle, however, we're doing that process manually. We're creating an event in one script and we're handling it in another script. And if you want everything done in a single script, then don't use events. So in this example, we are enabling an event from UI Manager. And since we're enabling this event in the platform data node script, we also define the event handling instructions within this script. Alright. So this is an event handler. So basically, if the Boolean program and the Boolean selected are true, then carry out this instruction. Okay, so now we can talk about Platform Manager. Alright, so again, we have delegates and event declarations. Again, we need events to be declared and created. Then we need events to be received and handled by other scripts. So here we are declaring two events, which are on Platform Manager, on Platform Manager changed, and then on Platform Manager update UI. Alright. So at the top we have on enable and on disable. Those are always going to be there if we're registering events and dereferencing events. So here we're enabling three events, which are build platform on click, on my program data, and scene loader. In build platform, we're simply right there. So right there, this is this third function right here. This is the instructions to be carried out when an event is triggered, and in this case it's build platform on clicked, right, which is what we registered earlier. So in build platform, we're simply pulling data from input PCD. It's an object created from platform configuration data, and if you don't remember, that includes data of our values for M, N, height, and spacing. So we're building a platform with that data. And that's the instructions that's going to be carried out when this event is triggered. So here we have an updated version of the scene loader function, and it's different from my part 2 submission. So if the current scene in the simulation, if the current scene is a simulation scene, we will change the values of the booleans. And then if it's the simulation scene, let's build a platform from file. If not, then just update the UI. Then if it's the program scene, in this case it's called programming scene, then let's change the booleans and build the platform with the build platform function, which is different from the build platform from file function. Okay, so next slide. Okay, so this is another update compared to part 2. I added the second if statement to destroy the platform program array, which is right here. And then this is another update compared to part 2. Now in addition to writing a file, we can build a platform from the file, which is called writelines.txt. And that is the end.